about possible further evidence for the autothixotropic phenomenon. So in short, that you will know what I will be talking to you about is about certain big gel-like phenomena found in water when it is rested for some time in small vessels. The content of my talk will be: first, I will explain the experimental background for my experiments. Then the method will be explained, the most interesting results, which are sweet and bitter. Discussion where I review other literature about similar phenomena found in water, and of course conclusions. So the experimental background of my experimental work was imprint of molecular information and unusual properties of water. For imprint of molecular information, I used epitaxy. Epitaxy is a word where it is mostly used for crystals, for building of crystals. It is transfer of molecular information from one substance to the other without mass transfer or chemical reactions. I wanted to observe epitaxy through mechanic treatment or through strong electrical impulses. By mechanical treatment, I mean altering of succussion, which is vigorous shaking, and dilution of water until extremely dilute solutions are prepared, where the chemical composition of those extremely dilute solutions is the same to that of the solvent. So the most interesting work for me was the work of Vittorio ELIA and his group from Naples. I even went to their laboratory to see how they are performing their experiments. They are exploring physical-chemical properties of aged solutions of sodium bicarbonate and found higher conductivity values in such aged solutions in comparison to the chemically analogous fresh solutions. They also performed other physical-chemical experiments, like, for instance, measuring of enthalpies, mixing enthalpies. So they found higher enthalpies of mixing with sodium bicarbonate, with sodium hydroxide, and different pH. Since the conductivity was the most interesting method for our work, I will explain more about it. So, I used electrical conductivity for my method, and since they found higher conductivity values in aged solutions in comparison to freshly prepared chemically analogous ones, I have to tell those who don't know what this means. Electrical conductivity is usually used to test how many substances are, or how many ions are present in solutions. So it is kind of a definition: higher electrical conductivity, higher ionic content. So if they observed higher conductivity values, they tried to interpret their results with transfer of proton by so-called Grott's mechanism, where the proton is actually tunneled through a solution by forming and breaking of hydrogen and covalent bonds between water molecules, and more are these water molecules ordered, faster is this transfer of proton. So that is how they interpreted their results, and they said that this water structuring is triggered by the self-ability of water to be to form clusters triggered by previous mechanical input of energy. So I wanted somehow to repeat the results, however changed some experimental conditions. I performed experiments at 2 different temperatures, at 4 different frequencies. I suppose that at higher frequencies and at lower temperatures I would be able to observe maybe more excess conductivity values. As I observed that when I measured the conductivities of fresh solutions treated mechanically or electrically and compared the results, so the first day after the treatment, I didn't find any differences. Therefore, I aged the solutions, so I prepared them really very carefully and sealed the vials either for 310 days or 370 days. The aged solutions were, after the conductivity measurements, chemically analyzed for all possible ions that could leach from glass: sodium, potassium, calcium, magnesium, silicium. We found, similar to ELIA, that the most important ion, highly most important ion, is sodium, which affects conductivity. Therefore, I made a calibration curve made of sodium bicarbonate solutions with different concentrations and compared the conductivity values of measured solutions with the theoretical conductivity values that should have appeared. So, aging at 310 days, for 310 days was performed at 3 different conditions. Solutions were frozen, protected from daylight and exposed to daylight, and for 370 days they were kept at 3 different volumes, 2, 5 and 10 milliliters. I tested repeatability of conductivity measurements by performing 2 different preparations of 30 solutions kept for 310 days, and I found this highly repeatable. So my results were bittersweet because I wanted to find some effects of this mechanical treatment or electrical treatment to the conductivity values. However, I didn't find any differences between the aged control solutions and aged mechanically and electrically treated solutions, which is somehow similar to the work of Olandino, who observed that the conductivity of extremely diluted Wien crystal sulfate has the same time-dependent evolution as inert distilled water. However, the influence of aging was very interesting. I found that graph you can see coefficients between measured and conductivity CCC. Conductivity CC, this means theoretical conductivity, which should be 100% if everything is okay. In this graph you can see that the interaction between temperature and frequency is significant, which means that at lower temperature and higher frequencies, higher conductivity values were found, or excess conductivity values were found in comparison to higher temperature. The influence of the contact hydrophilic surface versus volume was also highly linear. On this graph you can see excess conductivity values plotted versus ratio surface of end volume. And here on this graph you can see influence of condition, which was also significant, since the solutions that were kept frozen for 310 days showed no excess conductivity values. When you see, do you have a... The line here is the calibration curve made with fresh one-day-old solutions of sodium bicarbonate. So here are the solutions stored in liquid state. Here are the solutions stored frozen. The solutions, all the conductivity values should have been, according to chemical analysis, should have been somewhere near this line. However, all were above the line. So for instance, if I take this dot here, for this dot, the conductivity was around 50 microsiemens per centimeter. So its chemical composition should be around 0.5 millimoles per liter, which is more than twice I measured. So the highest excess conductivity values were found when the solutions were kept restrained from instrumental vibrations. Similar were also the solutions that were kept exposed to daylight. However, as you can see, when the solutions were frozen, no excess conductivity values were found. And the final plot I want to show you, which is very interesting, is the influence of ions. On this plot you can see dependence of conductivity values from concentration of sodium bicarbonate. Again, you can see the calibration curve. The blue plots, blue dots mean 310 days aged solutions under 3 different conditions, and the red dots are 370 days aged solutions in 3 different volumes. It's really interesting how you can see some linear correlations, which actually reminded me of an interesting paper from Turton and co-workers, who published that high concentrated electrolyte solutions give glass-like behavior. So, from our results, I can say that some certain time domain of water was found, and because I also attribute higher conductivity values to the better functioning of the Grott's mechanism, which is again attributed to the higher structuring of water molecules. So I think some large-scale inhomogeneities in aqueous systems should be present. Therefore, I think that my results are very similar to the results of VITTORIO and Voracek, who found that water, when it is left to stand in small vessels for some time, becomes gel-like, spontaneously develops gel-like behavior. So I reviewed literature for similar results. So besides from our increased conductivity values in H solutions and ELIAs as well, higher conductivity values were found always when water was under a constrained condition. Also enhanced thermal characteristics or thermal conductivity of water was found, which should be related to the electrical conductivity, since both phenomena are transported by free electrons. So I propose that these self-organizing properties could be explained by the quantum field theory, where also micrometer size domains, coherence domains can evolve. And since in this conference a lot of talk was about the coherence domains already, I just would like to add two interesting research papers that found two structured model of water. So again, according to the quantum fields theory, in water, coherent domains and incoherent domains exist, independence of temperature, and under certain circumstances, the coherence domains become more stabilized. Since water in mainstream science is considered as a homogeneous liquid, I'm trying to find literature about inhomogeneous structure of water. So I would just like here shortly to say, to note the two-structured model of Röntgen and the inhomogeneous structure found in water by Huang in 2009. So I further researched the literature, since the self-organizing abilities or self-organizing systems, they have like 10 main properties, and one of them is time dependence of their properties. So I searched literature for the time domain of water, and I found that water exhibits luminescence, and upon radiation, the spectral parameters of water are enhanced. And even when the source of radiation is switched off or removed, the spectral parameters still change. And this is not like 1 minute, 10 minutes, it is hours, days, weeks. Interesting for our research is also research of Rubisho from 1999, that the duration of storage of water also affects the spectra of water. It enhances the intensities in this spectra. And the time domain of water can also be observed by use of magnetic fields. We had a lot of talk about the influence of magnetic fields, and I only want to mention maybe the work of Higashi Tani, who did, I think, 10 years of research fields and found that the magnetic effects could be observed when the experimental conditions are appropriate. The magnetic effects are very sensitive to external influences. They found magnetic memory effect as well, and they found that discontinuous magnetic radiation has higher magnetic effects. So one work considering magnetic field was also very interesting to me, because they were measuring oxygen reduction potential of water and pH, and found that after that the values of this ORP and pH oscillated for some time after radiation was switched off. Afterwards, they came to an equilibrium position. The same was also observed by Gutko and co-workers for luminescence. So maybe water could be considered as an active, excitable medium. Some even think that it establishes the conditions for self-organization of systems. This was observed by Magnani and co-workers, who were exploring some peculiar, type of Belousov-Zhabotinsky reaction by using lamellar lipid structures, and they found that when the water content, in comparison to the content of lipids, was below 70%, the Belousov-Zhabotinsky reaction stops. So Marcantini and co-workers attributed this result to the special properties of water hydrating these lamellar structures, since they found a review of Henniker about water hydrating hydrophilic surfaces, and a few decades later Professor Pollack rediscovered this phenomena, which I have to say it's also a kind of epitaxy of hydrophilic surfaces to the water structure. So I won't go into the details about the properties of the exclusion zone water, but the most interesting property for me while reviewing the literature was that it expands by light, or expands by radiation, or as I found in many papers, that the spectral parameters of water, the intensities are enhanced upon radiation. So I think the time domain I found as I reviewed the literature, and also such formation of exclusion zone could be maybe further confirmation of this autothixotropic phenomenon. And I also thought that maybe some other large-scale inhomogeneities could be found in water. So I further reviewed the literature and found that at least 15-20 papers in very good journals, mostly obtained by laser light scattering measurements, they show slow relaxation modes in aqueous solutions with solutes that should be freely miscible. So, should be miscible with water. And Sedlak and Trapp, they made a really good experiment by using many different types of solutes like sodium, chloride, sodium sulfate, dimethyl sulfoxide, and others. And they used ordinary water, in this case I mean not degassed, and degassed water to be able to see whether the nanobubbles are the ones that are actually homogeneous in water. However, they found around 100 nanometer sized inhomogeneities in water, which were not nanobubbles in all cases. And here you can see a picture of such real discrete objects obtained in aqueous solutions of Ura by nanoparticle tracking analysis. And I think this could be further confirmation of the autothixotropic phenomena. So, to tell you again, or to remind you what is thixotropy. Thixotropy is a property of some gels and liquids that are fluid when they are shaken, and when they are rested, they become gel-like. Okay? The word comes from Greek tixis, and strepotixis means shaking, trepo means changing, and this thixotropic effect can be observed in clays, in paints, even in vanadium pentoxide salts, even human blood. But these are all high concentrated solutions. One good example of such thixotropic behavior was written in Polak's recent book. That thick albumin is dye-excluding gel. However, upon shaking, it becomes dye non-excluding salt. And what is actually important for the thixotropic liquids is that after infinite rest time, some non-rheological features change. And from these non-rheological features, there are the dielectric constant and conductivity. So I think this could further confirm that we interpreted our results in a good way. So the conclusions of our work are: what do experiments tell us about epitaxy, and what do results tell us about aging of solutions? So epitaxially, mechanically and electrically imprinted sodium chloride, under the conditions I used, does not affect the conductivity, even though it was aged. However, higher values of contact surface to volume gave higher excess conductivity values, which show another epitaxy, namely epitaxy of hydrophilic glass surface. In all 310 and 370 days aged solutions, except for those stores frozen, significantly higher conductivity values than in chemically analogous fresh solutions were measured. No excess conductivity values were found in frozen samples due to diminished translational mobility of water molecules in the solid state, and higher conductivities cannot be attributed to other ions than sodium, which was also measured, neither to absorption of carbon dioxide. So the new questions are: could excess conductivities be attributed to autothixotropy? I propose that yes. May quantum field theory explain the occurrence of the autothixotropic phenomena? I think yes. And could large-scale inhomogeneities form due to the increase of effective particle sizes by growth of exclusion zone water? So here are some of the published work about the phenomena, and thank you for your attention.
Thank you very much, Nana, for such a fascinating talk, so well delivered. So we're open for questions. We have just 5 minutes. Does somebody have the hand mic to bring over to this gentleman?
I got a loud
voice.
Loud. So, does that make a difference where you age the water? For example, if you age the water in a plastic bottle versus glass, have you done the...
You can't measure conductivity when water is aged in plastic glass, because plastic always releases some impurities that are actually organic acids, which really contribute to the conductivity. So you can't...
So you think this solidity has a lot to do with the surface of glass?
Yes.
Not the intrinsic, I guess, property of something in a bulk water?
Yeah, it is an intrinsic, I think it is an intrinsic property of the water, but it is enhanced by if you age solutions in small volumes, where the ratio between surface and volume is greater, is higher. You know, if you can't observe such a phenomenon in high volumes because it's very big.
But so it would be kind of a container depends. Like I guess if you had clay container,
yeah,
would that be different? Would that have different effects than glass container, for example?
I think yes.
Just one more question. Have you taken this water and run any spectroscopic measurements to see what it looks like?
Yes, actually I didn't take aged water for spectroscopy measurements. I only did, I performed UV measurements of, I think, 500 days old water sample, and they had the 270 nanometers peak. You know, the ones that Professor Pollack is observing in exclusions on water. But
okay, I have to interrupt. Is there anyone else who has a question? We have very limited time. Please, Harry.
Thank you very much for the talk. The conductivity measurements that you did was done at 3 different frequencies, 1 kilohertz, 10 kilohertz, and 100 kilohertz, right?
yes.
How did you pick those frequencies?
Well, I tried to find equipment which would, because usually conductivity measurement devices have the frequency of 1000 hertz or 3000 hertz, you know, and they don't really bother with this frequency. And I wanted to find a system that would measure conductivity, not the dielectric constant or something else, just conductivity. And this was the highest frequency for our financial abilities.
I see. Okay. Well, then I must say good job.
Okay, I'm afraid.
I would prefer higher frequencies, because I think at higher frequencies you can see a
Which will make a difference. Okay. All right, thank you.
Okay, thanks.